let's go on with relational databases. So now we switch to another example, university courses. I am pretty sure this should be a topic you know very well. So let's say for each you have to build a small two-table database. Just wrote a schema as we did previously. So the schema of the two tables and the relation between professors and courses. So I will write in Word just draw. Let's make it larger. The schema of a database to handle professors and courses. Okay, we assume that a course can have only one lecture. Usually it's like this, but there are strange courses with modules or with shared parts. So, but we assume that the course can have only one lecture. Obviously, a lecturer can have more than one course. Okay, now suspend the video, try to do it yourself, really do it, otherwise I'm not taking full profit from these lessons. And then resume the video and watch my proposal of solution. Have you suspended it? Okay, let's see my proposal of solution. Clearly two tables, one for professors, another one for courses. What could be interesting is the choice of primary keys, which fields are in which table, and in particular the relation. Let's go here. I will try to draw it with my new pen. Let's see whether I'm able to. Oh yes, here I am. Okay, so first table, professors. Let's call it profs. Okay. The pen is reacting terribly slow. It's not me that I'm unable to write. Let's choose this one. Maybe it's slightly better. Okay, which information do we have for professor? First name. First name. Last name. Birth date. Nationality. I can assure you that it's not me. Okay, and several other information. Which one can be a good primary key? Well, clearly none of this one, but since it's a database that probably will be used by the university, the text code, for sure the university knows the text code because professors got paid, something which should not be a surprise. So text code is the primary key. Okay. On the other side, we have courses. Okay, let's see. Which information do we have about the course? The name, the number of credits, the language in which the course is held, okay, and probably other fields, but which of these can be our primary key? Well, credits and language for sure not. Name, in theory, should be a good primary key, but as you probably know, if you're attending one of my courses, there are courses with the same name. Okay, so name is not a good primary key. The university has introduced a code, So a numeric code, which for my courses is 27006 or 27084, which is exactly perfect. It's a sort of ID, but decided by the university. Okay, how to connect these two tables? Okay, I will now do something which you should never do. Okay, there is a relation between the two tables. Or at exam or when designing databases for me, please never build a relation in this way, so without a specific field to attach the relation to. Okay, because I will mark it as a severe error because it means that you didn't understand anything from relational databases. The relation must always start from a field and go to another field. In particular, start from a foreign key and go to a primary key. Okay, if you build a relation like this, so you don't arrive to a specific field, you have not understood anything of a database, of relational databases. And there are still many people who at exams or homeworks do something horrible like this. Okay, so I start doing the relation like this, and then I ask myself, for each course, how many professors do we have? Well, for each course, we have made the assumption that there is only one professor. So on this side, it's 1. So 1 on this side. I will write it here. For each professor, how many courses do we have? Well, a professor can teach several courses. Well, sometimes can be also unemployed and doesn't teach anymore. So many in general. Okay, so a professor can teach many courses. A course is taught only by a professor. You can see that tables are objects, so nouns, while relation are verbs, so relation. A professor teaches, a course is taught. Okay, so this is a verb and these are nouns. So this represents action, usually and not always. Okay, so this side goes to the one side and therefore it must go to the primary key. There is no way. Okay, so the one side must go to the primary key. This side instead must go to a foreign key. So the foreign key must contain the same thing as the primary key, so must contain the tax code of the professor who is teaching. Well, but we don't have here anything similar, so you must add it. Let's call it teacher. Okay, this happens frequently. So frequently happens that you build a relation. On the many side, you don't have any field which is suited for the relation, so you have to add another field which contains the foreign key. This is more or less the field producer for the table wine and producer. It's the same role. Okay. It contains the text, not the name of the professor, but the text code of the professor. It must contain exactly the thing which is on this side. Okay, so the relation is this one. Pretty easy. Nothing strange, nothing particular. After you have built it, I suggest you to recheck. For each professor, there can be many courses. For each course, there can be one professor only. Okay, just to take a look at how would it look like, I will build it also in Excel using the other view, so the data view. This will look the professor table, rename profs, will look something like this. First name, last name, birth date, nationality, and text code. This is me, birth date. I am barely 18. Nationality and tax code. And blah 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 all the rest. Okay. The other table will look like this. So the course name, the credits, the language. Okay, the course code, for example, information systems and data, blah 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 blah. number of credits 5, language English, course code 27006. Okay, and here there will be a teacher, and here you will see my text code. So, okay, and so you join these two fields. Okay. Okay, remember the foreign key must contain the same type of field as the corresponding primary key. It doesn't contain the name of the professor or something else. Okay, and that's it for university courses. Let's see the one-to-one and the many-to-many relations. Okay, well, the one-to-one relation are so silly that it's difficult for me to find a suitable example. Well, I have here an example, countries and flags. Okay, that's it. And imagine you have two tables, a table of countries, well, I'm improving, with fields, for example, name. Well, name in theory is a primary key, even though there are strange countries with the same name. Continent. In which continent is the country? Even though there are countries which are in two continents, however. Size. Population. Okay. Imagine here you have flags. Again. Last attempt. Okay, do on the other side. Okay, flags have a picture, which is the main information after all, a shape, because not all flags are rectangular. There are some which have odd shapes. Description. Which is the description of the flag. Well, in theory, picture is the primary key because the flag itself. Okay, but for Node, I think no database program will accept a primary key which is a picture and not something numeric or alphabetic. So let's use ID here, which is the primary key for flags. Okay, there is a relation. Which relation? Each country has a flag. One flag. Each flag, excluding very particular situations, so we just stick to the basic situation, let's say Europe. Each flag belongs only to one country, so the relation here is 1-to-1. Okay. Well, in theory, I should attach the name of the country with the ID of the flag, but I can't. So I must build, for example, here another field which is called name. Okay. However, all this thing is totally silly. Easier to erase it. All this thing is totally silly because, honestly, well, I could do instead something like this. Let's change color. Take this entire table and move it here. So, literally, I could add here flag pictures, flag shape, and flag description. okay, and forget about this table here. So whenever you have a one-to-one relation, even to some of you write here infinity and pretend that it were a one-to-many relation, so but a counter cannot have many flags. Okay, so whenever you have a one-to-one relation or a one-to-many relation, but which in practice is a one-to-one relation, well, you don't have to divide the thing into two tables. There is no advantage. You take all the meaningful fields of the second table and you add them to the first one. Okay. Another typical example, which happens to me frequently when I correct exams, another frequent mistake. Let's go back to black. Do I have black in these 200 colors? No. Let's produce it manually. Can I have black here? Doesn't seem so. Okay, let's hope it's black. Light gray. Is it so difficult to have it black? Okay, this should be black. Okay. One of the main thing is whenever you add a table which contains details. For example, I have a table containing rooms of an hotel. Okay. Well, you have all the room details, so for example, all the room information, so for example, the room number, which will be also a primary key, the room size, the number of beds, etc., the floor. And then rooms in an hotel can have a lot of other features. For example, does the room have a table? Does the room have a large bath? Does the room have an extra small bed for children? Does the room have air conditioning? Okay, you could add all this information here without any problem, but some of you, for mysterious reason, probably to enlarge the number of tables, write here extras. Small bed, air conditioning, air conditioning, table, the sofa. These are all fields which are yes, no. So yes if the small bed is inside, no if it isn't. Okay. Then ID, primary key, and here extras. Okay, many of you do something like this. Okay, in theory, this relation here is a many-to-one relation because each room has only one combination of extras. Well, we call this table extras, but the name will be combinations of extra equipment. Okay, so each room has exactly one combination. For example, a room has the small bed but doesn't have the air conditioning, has the sofa but doesn't have the table. Okay, but what is surprising is that a combination of extras can belong to several rooms. Well, unless your hotel is extremely large and well standardized, for example, 50% of the room have air conditioning but don't have the sofa, 25% of the room have the small bed but don't have the table. So unless your hotel is very standardized and very large, okay, I don't believe that each combination of extras applies to many rooms. Usually each combination of extras applies to one room only, especially if the combination involves more than 4 fields. So sometimes it happens that you build this kind of thing, which honestly there is not too much reason. You could take this is a many-to-one relation in theory, but in practice it's one-to-one because each room has its own particular combination of extras, especially if you include something such as sides. So if you put sides here and you don't put it here, okay, now I do not believe that you have rooms which have more than one room which has the same extras and exactly the same sides, unless your hotel is very well standardized. Okay, so if you are running an hotel in Las Vegas with 500 rooms, probably so standardized that the same combination applies to several rooms, and so it's worthwhile to split the two tables. But if you're running a small hotel, the same combination probably applies to one room, so it is not a many to one, but a one to one, and you could move everything here. So there is no reason to split the two table. So several times you split artificially a table in two parts, you build a many to one relation which may be completely wrong or may be in theory correct, but in practice I hardly believe that it's necessary a many to one relation. Okay, so one to one relation are absolutely to avoid. Another issue which is much more complicated are many to many relations. Let's see. Okay, we talk about houses and property. Let's see, have here. Okay, houses. Okay, I have my usual list of people. These are my friends, if you recognize them. Okay, my 8 friends. Okay, with this time with a tax code because I pretend to be the special office which is in charge of writing down all the ownership of houses. So the issue here is who is the owner of a house. Okay, so I have the list of people, the list of houses. Okay, so let's see the field tax code. Okay, name, surname, birthday, birthplace, province, country. That's it. There could be other several thousand fields, but they're not necessary. For what is concerning houses, before switching, stop the video and try to find yourself several fields for houses. I think at least 10 you should find. Okay, resume the video, let's see. I have only 4 because I'm lazy. House code is just an ID which identifies the house. Okay, the house could be identified from the address, but sometimes the 2 different apartments share the same address, so it's not so. Okay, the address, the town, the floor, okay, and several other fields could be, for example, the sides, the number of rooms, the number of bathrooms, whether it's a full house or just an apartment, etc., 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 etc. The official value, the tax value, etc., 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 etc. So we have these 2 tables. I will now stop the video and draw them myself, so I don't waste your time. Okay, let's resume the video. As you can see, my drawing skill have dramatically improved. Okay, now let's see which kind of relation do we have between table people with tax code, primary key, etc., and table houses. With houses I mean basically apartments, as you can see. Okay, for each person, well, you can have several houses because a person can own many or just one or no house at all. So the relation for each person, let's see, can have several houses. On the other hand, each house can be owned by, well, by several people, because while many houses have just one owner, there are houses which have more than one owner, typically 2 husband and wives, okay, or brothers, or a house can have owners in different times. So there was an owner before and now it has changed. So also here several. Okay, so the relation is clearly many to many. Okay, now when a relation is many to many, relational databases cannot handle it. So there is no way for us to draw a relation between a foreign key here and a foreign key here. No, it's not possible. When the relation is many to many, we need oops, I deleted too much. We need absolutely to insert a junction table in the middle. Okay. So we need to insert in the middle. Let's see whether another table. Oops. Maybe not so black. Okay. Okay. This table is junction table. It's called technically a junction table. For the moment, we give a temporary name, which is who owns what. So it's a junction table which replaces the act of owning something. So who owns what? Okay. The junction table is built always in the same way. It has a field which is a foreign key for the left table, so owner, tax code, and a field which is a foreign key for the right table, so house code. Okay. And can I have, let's use this. Okay, let's keep it like this. Okay, on the other side, same thing. Opete. Wow. Okay, let's write here 1, here 1, here infinity, which unfortunately I don't have on my keyboard and have to do it by hand. Infinity here and infinity. Okay, this table has obviously also an ID, which will be the primary key. Okay, and it could have other fields. We'll talk about that later. Let's review now for the moment the situation. For each person, there could be many ownerships. So we can call this table also, if you prefer, ownerships. So for each person, there could be many ownerships. Each ownership act has only one person. Okay. For each house, there could be many ownership, and each ownership act has only one house. Okay. This means that if several people owns the same house, okay, there must be several records here because each person has only, each ownership contain only one person, so there must be several records here. Since I imagine you don't have a real grasp, a real idea, a real view of what does this table contain, I have prepared also the Excel version, which is much more user-friendly. We have here the people table, the houses table, and the table which I call property acts. So instead of ownerships, I call it property acts. You can call it ownerships. Okay, you can see it contains simply the house code, the tax code of the owner, okay, and how much does it own. So this person owns house TN 44 100%. This person owns house 100%. These two people, you can see, look at record here 6 and 7. The two people own the same house, okay, 50% each one. So we can add here percentage. Okay, so whenever more than one person owns the same house, since each record can contain only one person, because the relation is each record here contains only one person and one house. Okay, if more than one person owns the same house, you can share it in this way. So same house, two different people, and the percentage. Same thing here, same house, two different people, and the percentages. Okay, so this table, technically called junction table, works basically like this. It contains simply the primary key of the left table, this one, the primary key of the right table, this one, and that's it. So it connects somehow the left table with the right table. The primary key of the left table can appear several times in case the person on the left here, in this case this one, has more than one house. Let's see, is there anybody who has more than one house? No, nobody. Okay, but it could this one. This person has more than one house. Okay. Also here, the same house can appear more than one times in case the house property is shared, as you can see for this one and for this one. While here and here, the same person own two different houses. So this is a trick, and it's the standard trick to deal with many-to-many relations between two tables, because there is no other way. You cannot connect the two tables directly. Please, connecting the two tables directly with a many-to-many relation, okay, like this, for example, many and many, it's a severe mistake. Okay, a junction table must be put in the middle. Okay, which other fields can we put in this junction table? Now stop the video and think at all the possible fields that you can put in this table. Okay, we resume the video. I will write some possible fields. A very interesting field is a date by date. Or more than by date, acquire date, because you can, not necessarily you bought a house, you can have it from your as a legacy, okay, or you can have it for other reasons. So acquire date, okay, the date when you bought or when you had the house for some reasons. Okay, it goes here, not here, and not here. Okay, if you put acquire date here, so let's write it in. If you put acquire date here, it means that automatically all the houses that you acquired in the past or in the future have been acquired on the same date, which is absolutely silly. Even worse if you put it here. It means that that house can be acquired only on this specific date. No other way. Here you can put instead, a reasonable field could be building date. So when the house was built. Okay. Okay. Other fields which can be put, and a very important field is sell date. Why do I tell you that it's a very important field? Well, because if you don't put sell date, what happens? It happens that whenever, look at the practical example here. Suppose that I sell my 30% of house BZ B034 to this person here. Okay. So it means that we must enter the database and modify my ownership with the ownership of this person here, Ferrari Maria, I imagine she is. Okay, in this way. Done. When I do this, automatically my house has been sold to Ferrari Maria. My 30% has been sold to Ferrari Maria. However, we don't have any historical record of who was the owner before, apart from by date, acquire date, sorry. Okay, so when I sell it to Ferrari Maria, and today imagine it's the 21st January 2017, okay, we do write that the selling has been done on the 21st January 2017, but we don't have in the entire database any information of who was the owner before. Well, in a database like this, it's very important information because there could be legal issues or things like that, and you must trace back who was the owner before. So how can we do it? So how can we insert the information that Ferrari Maria is the current owner, but that the house was mine before? Now, sorry, I write just a fictitious date for everybody. Okay, just a fictitious date. So the only way to handle the historical information is inserting also the sell date. Sell date is a field which is empty if the house has not been sold. So if this house belongs to who is this? Luigi Rossi. Okay. Sell date is empty. If I sell my house on the 27th January 2017, I will insert a sell date, and this means that the house was owned by me from this acquired date to this sell date. Okay, and then I have to insert a new record. Okay, with Ferrari Maria, record number 11, starting from the 27/1/2017 and with sell date empty. So inserting this record means that the house, sorry, Ferrari Maria, not myself. Where is Ferrari Maria? Oh, I lost Ferrari Maria, damn. Okay. So. Okay. Now, this record means that Ferrari Maria is the current owner, or starting from 27 January 2017. And this record means that I was the owner here. So, if you decide not to insert the sell date field, your database is static. It means that your database is just a picture of the current situation. Okay. It's an up-to-date picture, but you don't have any historical information. If you, on the other hand, just add this field sell date, it means that whenever the situation changes, you don't remove the record or modify the record. You just add a sell date, so you mark this ownership as over. When you have a sell date, this ownership is over, and you insert a new ownership here with the appropriate starting date. So this happens in many databases. Just adding an extra field containing a date, such as here sell date, converts your database from a static database, so a picture of the current reality, to a dynamic, to a temporal database, so a database which also keeps the historical information. Okay. And we have done also the temporal versus static databases. Oh, let's see a similar example, student and exams, which I imagine it's pretty familiar to you. New. Okay. Enlarge. Okay. So, as you can imagine, students pass several exams, I hope for them. And each exam is passed by several students, unless it's extremely difficult. So the relation between students and exams is clearly many to many. So now I suggest you to stop the video, really do it. If you just watch this video on a constant flow, you are missing a big opportunity. So stop the video and build a student table on the left, an exams table on the right, find the appropriate junction table in the middle, build a relation, give the junction table a correct name, and find all the fields which can fit in the junction table. Good work. Okay, now we resume the video. I built the students table on the left, the exams table. With exam, I mean a course, so the exam table on the right, and then the junction table later on. This is students. Oh, students have, and this is exams. Student have, well, first name, last name, birth date, birthplace, email address, nationality, and several tons of other fields. Okay. Which field can be used as primary key? Well, we could use the email as primary key because I expect that two students don't share the same email. But since students have the bad habit of changing the email frequently, the personal one at least, okay, the university doesn't trust using the email as primary key, and the university has a student number. Okay, I'm sure you have a student number on your student card, or at least you know it very well, which is the primary key used by the university. So the university has introduced this student number as primary key. Exams have a name, have an amount of credits. Okay, we'll talk later about the lecturer, so the professor. For the moment, name, that's it, nothing else, and have a exam code, which is the code of the course. So 27006, 27084, 27000, etc, etc, etc. Oh, I built a big table for nothing. Okay, now the relation. The relation is clearly many-to-many, as we have seen, so we need a junction table in the middle. Okay, the junction table for the moment will be temporarily called who passes what and contains, well, the student and the exam, the ID. For the moment, nothing else. The ID is the primary key. Student, exam. It's always built in this way. It always go to the junction table always contains only foreign keys. Okay, we have everything? Yes. Okay, first of all, let's find a suitable name for this table here. Well, what does this table contain in practice? Well, you probably are too young to have seen it, but this table is the equivalent of the paper book that I used to have several years ago, in which I wrote with my own pen the name of the student number, the name of the exam, the code of the exam, and the several other information, and then I signed, or when I was a student, somebody signed to register the exam. So this is the electronic equivalent of the exam register we used to have several years ago. So let's call it in another way. Oh, this name is fine. You don't need to change name. I change name just to give it a more meaningful. Exam registers or register. Okay. So it's a book which contains all the single exams. So in this, what do we have in this book? We have the name of the student and the exam. If your number appears in this register, it means that you have passed that particular exam. So if I see your number here and 27006 here, it means that you have passed my exam 27006. Okay. If it doesn't appear, you have not passed it. So passing or not passing an exam is just a matter of two numbers written here or not. Okay. Obviously, there are thousands of other fields which can fit here in this structure. Now I suggest you to stop the video and try to put as many fields as you can in this table and decide whether some fields can go here or some fields can go here. Okay, now you resume the video. Let's see which fields. The first one, which I think it's pretty obvious, the date. So the date in which you passed the exam. So if I see your number and my exam code, at least I would like to know also when did you pass it. Okay, but much more important, the grade. Okay, pay attention that the grade goes here. It doesn't go here. Because if I put grade here, it means that this exam has always the same grade, regardless of who passed it. Okay, I know probably there are some exams in which a professor gives always the same grade, but this is not something we would like to see. So the grade depends on the exam and on the student. Okay, not only on the exam or only on the student. Okay, there are some students who always got 30, so we could write grade here. And also the loud, whether you got allowed or not, this is a yes, no field. It's set to yes if you got allowed, it's set to no if you didn't get allowed. Okay. Some other fields, well, the fields professor. So who was the professor who was in charge of that exam? Let's say the president, officially the president of the commission, the president of the exam commission. Okay, well, where do we put it? We could put it here, or here, or here. According to where do you put the professor, it changes completely the meaning. If you put the professor here, it means that this professor is in charge of this exam forever and ever. If this professor dies suddenly and sadly, you will have to change the exam code, okay, because his name is written here. You cannot change the name of the professor, because if you change the name of the professor, all the people who took the exam several years ago with this professor will suddenly see the name changing, which is not true. So if you write the name of the professor here, it means the professor's name is bound forever with this exam. If the professor disappears, also the exam doesn't exist anymore, you have to change the name. So this is usually not the case. Even worse, if you put the professor here, it means that a specific student has only one professor. Silly. Yeah, then professor, the best place is here. Professor. Okay. It means that when you pass an exam, a specific professor was the president of the commission, of the exam commission. It could change when the student changes, especially when the date changes. And also, it must change when the exam changes. Okay, so the best place is here. Even though here it's acceptable, okay, the best place is obviously here. If you put it here, if the professor changes, the people who have taken the exam until now will have the old professor written, and the people who will take the exam in the future will have the new professor written. If you put it here, well, when it changes, you have to change it here, and you will change also for the people in the past, which is not correct. By the way, if you want, you can just write professor and put here the professor family name, surname, and that's it. But if you would like to build a much more complete database, let me you could have the professors table here. Professors with the usual field, first name, last name, tax code, birth, place. Writing with the keyboard is much faster. Birth date, tax code, by the way, it's primary key. Okay. And build a relation like this. commission president 1. Okay, so you can see that a junction table usually connects only two tables, but if you want to add other things, it can connect also other tables. There is no rule. Okay, so a junction table can connect if you want more than one table, okay, without any problem. Okay, we stop here for this lesson. If I can stop the video.